Welcome to this educational video about nuclear energy, with a focus on thorium, one of the most promising elements in nuclear research. Today, we will explore what thorium is, why it's significant, and how it can revolutionize the future of energy. In a world where the need for clean, efficient, and sustainable energy is at an all-time high, thorium offers an alternative to traditional nuclear fuels. So, let's dive into the facts, chemistry, and statistics surrounding this remarkable element. Thorium. The basic thorium, a silvery metal, is named after Thor, the Norse god of thunder. It's a weakly radioactive metal and can be found abundantly in the Earth's crust far more than uranium, the traditional fuel for nuclear power. In fact, thorium is about 3 to 4 times more abundant than uranium. Thorium's atomic number is 90, with the symbol Th. It has an atomic weight of 232.04 grams per mole and belongs to the actinide series on the periodic table. What makes thorium particularly exciting is its potential to be used in a thorium fuel cycle for nuclear reactors. Unlike uranium, thorium cannot sustain a nuclear chain reaction on its own. However, when bombarded by neutrons, it transmutes into uranium-233, which is fissile and can sustain a nuclear chain reaction. Advantages of thorium over uranium. One of the biggest advantages of thorium is its safety profile. The thorium fuel cycle produces far less nuclear waste than uranium, and the waste it does produce is far less hazardous. While conventional uranium reactors produce long-lived actinides, the thorium cycle minimizes these dangerous byproducts. Abundance. Thorium is about 4 times more common in the Earth's crust than uranium, making it a more sustainable resource for long-term energy generation. Less waste. Thorium reactors produce up to 1,000 times less waste than uranium reactors, and the waste that is produced has a much shorter half-life. Proliferation resistance. Thorium does not easily produce materials suitable for nuclear weapons, reducing the risk of nuclear proliferation. Statistics on thorium. Currently, the global reserves of thorium are estimated to be around 6.2 million metric tons, with significant deposits found in countries like India, the United States, and Australia. India alone holds 25% of the world's thorium reserves, positioning itself as a key player in future thorium-based energy systems. India. Estimated thorium reserves 846,000 tons. United States. Estimated thorium reserves 595,000 tons. Australia. Estimated thorium reserves 489,000 tons. If thorium reactors were to replace conventional uranium reactors, they could significantly reduce the environmental impact of nuclear energy. Thorium-based reactors also produce 50% to 60% less plutonium compared to uranium reactors, which is a key factor in reducing the risk of nuclear weapons proliferation. Thorium fuel cycle. The thorium fuel cycle works by converting thorium-232 into uranium-233 through neutron bombardment. Uranium-233 is a fissile material, meaning it can sustain a nuclear reaction. This process occurs in several steps. Thorium-232 absorbs a neutron and becomes thorium-233. Thorium-233 quickly decays into P-rot actinium-233, which then decays into uranium-233. Uranium-233 undergoes fission, releasing energy and creating more neutrons to sustain the chain reaction. In comparison to uranium-235, thorium has a much higher burn-up rate, meaning more of the fuel is consumed during the reaction, leading to less waste. Thorium reactors. Several countries are researching molten salt reactors (MSRS), which are well suited for using thorium as fuel. In these reactors, the fuel is dissolved in a molten salt, which serves both as a coolant and a fuel carrier. MSRs are inherently safer than traditional solid fuel reactors because the fuel can be drained into a passively cooled containment chamber if the reactor overheats, preventing a meltdown. India, for example, has launched the Indian Thorium Energy Program and is working on advanced heavy water reactors (HWR) that will use a thorium-based fuel cycle. The goal is to make thorium reactors the backbone of India's energy grid in the coming decades. Safety and environmental impact. Traditional uranium reactors come with the risks of meltdown, as seen in past incidents at Chernobyl and Fukushima. Thorium reactors, particularly molten salt reactors, mitigate many of these risks. MSRs operate at atmospheric pressure, reducing the chance of an explosive release of radiation. Furthermore, thorium reactors can operate in a closed fuel cycle, continuously using thorium fuel with minimal waste. The half-life of thorium reactor waste is much shorter than that of uranium, making it less hazardous over long periods. Waste from thorium reactors is mostly safe after 300 to 500 years, compared to the thousands of years required for uranium reactor waste to decay. Thorium's potential. In the future, thorium has the potential to power clean, safe nuclear reactors for centuries. With the growing concerns over climate change and the need to reduce greenhouse gas emissions, thorium-based reactors could offer a significant part of the solution. Unlike fossil fuels, thorium does not produce carbon emissions, making it an environmentally friendly option. However, despite thorium's advantages, it still faces several challenges. Current nuclear reactors are designed to run on uranium, and transitioning to thorium would require significant investment in research and infrastructure. But with more nations like India pushing for thorium-based reactors, the future of nuclear energy may lie in this underutilized element. Thorium provides a safer, more sustainable path forward for nuclear power. While it may not be the solution to all of humanity's energy problems, it offers a compelling alternative to traditional uranium-based reactors. Thank you for watching this educational video on thorium and its potential to revolutionize nuclear energy. If you found this information useful, consider subscribing for more content on science, technology, and the future of energy.